Hi, everyone. Quick show of hands. How many people think they have an idea of what REST is? OK, just about everybody. I just want to get that. And how about JSON? OK, good. I've got a few extra slides. I wanted to know if I needed to use them or not. So a little bit about me. My name's Joan Tuzet. You can find me at Wahali on IRC, Twitter, you name it. I'm a senior field and development engineer at Cloudant. I'm proud Torontonian, hooray, Canada. Pythonista, Erlanger, big into IRC. I've been involved in IRC daemon development for about 20 some odd years now. Verilog, MIDI, etc. So what is Cloudant? I'm guessing most people have not heard of Cloudant here, right? Yeah, it's pretty common. How many people have heard of CouchDB? OK, good. So Cloudant is a data layer that's modeled after CouchDB. In fact, it's built on top of CouchDB. Standard marketing slide, not a lot of exciting stuff here, except to understand that we've got a lot of folks that use it. Anybody here know of Hothead Games? No? All right. I've got a slide on them in a second. But basically, we've extended CouchDB in a number of ways, founded by 3 data scientists who were using Couch and other similar technologies with the Large Hadron Collider. And obviously, we're managing huge volumes of data. So to give you a sense of the size of the stuff that people tend to use our platform for, this is from the London 2012 Olympics. These guys pulled streams out of Twitter, pulled the hashtag London 2012 out of the fire hose, dumped it into our system, and then used it to do an integration of people's emotions over time, which is kind of a classic Twitter analysis sort of thing. But this is the first one I knew of that actually displayed it on a giant light show. So they used the London Millennium Eye Ferris wheel to display whether people were happy or sad. And every night had a 30-minute light show that reflected how people felt about tweets during the day. It's kind of neat to see the platform that you've been working on and supporting in huge, huge lights. Here's another one, Hothead Games. These guys are indie game dev studio out of Vancouver. Go Canada, again. They launched this title, Big Win Soccer, and it was highlighted on the iPhone App Store. Within 2 days, it became a #1 app on their store. So you can imagine a little bit of a challenge in terms of scaling the back end there. We're their back end for data, and we took them from a 6-server to about a 60-server cluster in about 16 weeks of work. And as you can see, the types of data that they're driving through this, 80 million games played, 100 million packs of cards, that's a thing you can get in the game to give you an advantage, 500 million documents in the database, and about 20 apps opening every second. So pretty serious load here. And this was just in August. So since then, they've added another big game. So they've got Big Win Soccer, hockey, baseball, and football now. They got another feature spot on Google Play. And we've had to add another 24 servers to that cluster. So it's a big, big amount of data. In fact, right now, we're around 131 terabytes. It's about 8 trillion input-output operations since we've started recording this data. And there's about 3.5, 3.4 million databases. This number fluctuates widely, this last one. And you can hit that endpoint right at the bottom there, and you can pull our live data anytime you want. You'll get this JSON document back. And so it's all via REST and JSON, 100% of it. And it's all in Erlang with a bit of C. So why am I here talking at a Python conference? Well, the reason is I play a number of roles in Cloudant, but one of the main ones that I spend a lot of time doing is in DevOps or site reliability engineering or whatever you'd like to call it. And our days pretty much consist of sitting at a console of significant numbers of tools and buttons and features like the Apollo mission consoles. This is a great article that was, I think, on Ars Technica recently, where you can actually look at all of the Apollo mission consoles. They detail what all the buttons are. For a geek like me, it's really neat. And so it pretty much consists of people coming and saying, could you just do this one little thing for me and make this work? And then you go and you figure it out. And then somebody asks you to do it again, and you figure it out again. And eventually, you start building this up and aggregating it into scripts that you run. So we have an internal tool we've written called Clue, which is the Cloudant command line utility. And it has sort of your standard command line interface. So you can say things like clue user info and give it a username. And you'll get back things like the username, their email address, what cluster they're on. We've got a number of multi-tenant clusters. We have a number of private clusters as well. And you can also see the history of where somebody's been. Whether they're paying or not, I'm not paying, I'm lucky. The date the account was created, and then a rough estimate of what the data size is at this particular instant in time. So stuff like this is pretty simple. This is just grabbing a couple of documents off the back end and displaying them in a simple-to-use fashion. And it's grown over time, especially with the history field, because some of this was important. People wanted to move around and didn't know where they were. But there are some more advanced things that Clue can do, and I realize this is a small font. I do apologize. I'm going to make sure the slides are available after the talk. But if you want to move a user, today that's not something that we allow people to do directly through the web interface. We've got 5 or 6 shared multi-tenant clusters. If you're on one cluster and you'd rather be on another one, you fill in a ticket on our website, and a human actually responds and triggers on the back end this command, clue user move, username, and then the cluster that they're going to move them to. And it does a number of different things. So CouchDB is well known for its ability to replicate data seamlessly, effortlessly. That's the first thing we do, is we replicate all of your databases from the cluster you're on to the cluster that you're going to get to. And then the next thing we do is we change your user document so that we know that you're now living on this new cluster. We then go out and refresh our load balancers to let them know that your backend is now going to be hosted on a different cluster. Finally, we update DNS so that here wahali6.cloudant.com points to the new cluster, not the old cluster. And obviously, there's going to be a period of transition during which DNS isn't updated everywhere, or it's been cached, or there are live connections to the old cluster. So it's a multi-step process. And it's also not something that always goes as smoothly as you might like. Some of these databases are quite large. 10 megs isn't a really big deal here. I've only got 2 databases. But when you're dealing with a user that maybe has some of these terabyte-sized databases, it's the sort of thing where it was very important traditionally for us to be watching that, making sure that it did the right thing. If something got interrupted in the interim, say, between my machine and the cluster that I'm running this on in the cluster, or the cluster was going through some other reconfiguration that might cause problems, we might need to go back and selectively reapply some of these transformations. So over time, obviously, this has not been a particularly it's been an incredibly useful tool for us, a great thing to build, a lot of fun, but it's not necessarily the right way of going about doing this sort of thing. And then somebody comes in and says, we need to remove this baby's ear. I just found this morning, sharpsuits.net. It's some charity thing in Ireland of advertisers who made fun of the crazy requests that they were given. So what we decided to do was take the next step in automating some of the things that we do. We created a project called Wilson. Wilson, named after Earl Hindman's character on Home Improvement, Tim Allen's sitcom from the 90s, 20 years ago. He's sort of this empowered Superman who knows how to do what you don't, and you can go and ask him anytime to help you out. He's on the other side of this fence from you, so he's an entirely a REST API, which is a great match for our technology. And he's serving both admins and users without prejudice, so understanding the types of requests that you need, the things that you need to know about, and helping you out. And just like our core database offering, it's all in JSON. Thing is, this may sound like a great intern project, but it's not as simple as it looks. Cloudant's infrastructure is quite complex. We have many different data centers with many different providers out there. Some of these data sets are absolutely massive, like I mentioned earlier. We have multiple operating systems, so most of it is Linux. We have some in SmartOS. We've got different varieties of Linux that are out there. Some of it is operating over the public internet. Some of these are not areas where we have a private VPN into these clouds that are provided. Sometimes it's actually within a customer's VPN. So we've done this co-managed solution where it's their cluster but we're running it for them on their network, but we can only sometimes get in, and we might have to do 2 or 3 hops to get in there. And there's also the idea of, at some point in the future, it might be nice if we could actually hand the whole thing over and say, well, here you go, now you're running this. Now, how are you going to do this? We can't expect them to use Clue. I mean, it's nice to have a CLI, but it's not a CLI that's designed for somebody who doesn't know what they're doing, or somebody that just wants to get this operation done and doesn't understand, hey, some piecemeal piece of it didn't work, how do I recover? So our backends today, obviously there's Erlang. There's Python with no framework like Clue. Some of our API endpoints that are on the Cloudant public website are in Django, and some of it, unfortunately, is in Node. And it was basically written in the language that the dev who was responsible for the task knew best at the time. It was organically grown, it did the right thing, we filled in our holes, but it wasn't necessarily designed as an actual application. So our goals, and this is going to be introduced next quarter, is we're going to have 2 backends. Obviously, we're not going to lose Erlang, because it's our product. But we're going to add Python and Flask, and probably GUnicorn. All right, so why Python? Well, there's how many people actually understand the engineering behind the term impedance mismatch? Okay, just a couple of hands. The idea is that if you have some widget A that produces a signal and some widget B that is going to receive that signal, the load that B puts on A affects the way the signal is transmitted. So without an impedance mismatch, if the load that B puts on A, and I realize I'm mangling this, I am an EE, but I'm trying to explain it without too much EE. The load that B puts on A is going to affect both the current and the voltage of the signal, as well as the load that the actual connection between the two has there. So on the right side, if they're not matched, then what you get is a reflected signal that heads back to A, and that ends up reflecting back to B, and you get this ugly ringing on the line, and you get all sorts of ugly stuff. You don't get a pure signal. Well, that's a perfect example of why just building everything in Erlang is not really a good choice for us. Some tasks are just more procedural. Erlang is a great functional language, and it's a perfect match for the type of MapReduce things that CouchDB does. But doing things like a user move, a password reset, some of our cluster admin tasks, we have this thing we do where we deploy emergency fixes, and Erlang is amazing for its ability to hot patch code. It's really, really cool. Billing, marketing, this stuff is not really a task for Erlang. And apparently, this cable does not want to stay in my laptop. Let's hope that doesn't die. This is the coldest conference hall I've ever been in. All right, and again, a good example of the Apollo mission manual. This was recently auctioned off. It's a page from Apollo 13 about how to get the heater restarted. So Python made perfect sense for us. So why Flask? Why didn't you just stay with the Django framework that you had? Why not use one of the other ones? Well, a minimalistic framework means a huge amount to us. We are not a relational database backend. It doesn't make any sense for us to have an object relational mapping layer at all. Most of these tasks are covering data and multiple operations that are already stored in this amazing NoSQL type backend. In addition, we already have authentication and authorization in this system. In fact, you can think of it almost as a, quote, legacy system where all of that functionality is there and we're just adding extra pieces to it. So we don't really want this heavyweight framework that imposes a coding style on us. We just want to do good REST work. So again, a good match with our API. It's more mature than Bottle, we think. We love the documentation. It's got a great ecosystem. Very happy with all of that. And it is really, really quite simple. Add a decorator, put the URL where you want it to go, declare the methods that you want, and you just have it, and you just return what you want. And since we want it to be in JSON, we can just JSONify it. A little bit more of an in-depth example. I realize this is going to be harder to see. We also like using a class-based approach where we declare methods that say, that are the verbs that are used in REST. So def init, and then on the next slide here I have def get, def post, def put. Very simple. We require a user here. This is an example of our ticketing system. We do our ticketing in FogBugs for support. And we wanted to allow the front end and our website to be able to pull out lists of stuff out of FogBugs. So the API that supports that grabs our internal app config for user and password. We also have a mocking system built into this. So we're able to mock the interface and make sure that that comes back correctly. Obviously, we're at cloudant.fogbugs.com. And then when a user says, I want to get my tickets, we're then, like Wilson, making a decision on the other side of the fence for them, using our login to get the list of bugs that have that person's username in it. And this isn't exactly what we do, understand. It's slightly censored. Get the tickets, show them by default the top 5 tickets that they have. We currently are just emitting what the limit is there on a debug statement. And we slice it out. We return a new JSON dict and then JSONify it back out. So other advantages to this system, it's really, really easy for our new employees to jump in here and start coding an endpoint. That ticket thing was done in like an afternoon, right? Very, very simple. FogBugs works for us. We want it on the website? OK. Here's how we do it. Really flexible for temporary needs. I say temporary, easier to integrate with a system. Marketing tends to like to change which library they like to use for tracking users. So the ability for us to just, on a dime, stop and say, OK, we're not using library X, we're using library Y, and we want to track users a different way, is really key. And in true Tim Allen fashion, it is easy to add more power yourself. What does our ecosystem look like? So obviously GitHub. Wanted to put a little plug in for Travis Pro. These guys have been doing amazing work. This is a new commercial offering they've got. And you can see here we've got Wilson, and it's doing live builds for us in 2.6, 2.7, and PyPy on our private repo. So if you've not looked into that, I believe they're going into public beta as of 3 days ago. Requests, thank you, Kenneth. I guess we'll be talking tomorrow. Unit test, we use the unit test library. We use the nose test runner just because we like it, and the mock library. We're actually using pip and a setup.py for our own stuff, so it's easy to get out there. We use Chef. I know it's a thing, right? And Sphinx for documentation because it's just easy. Might know one of the thing you might have saw that I mentioned, GUnicorn, PyPy. There was this great blog post about 2 weeks ago comparing performance of different frameworks. And we have a vested interest in this because one of my coworkers is Paul Davis, the co-author of GUnicorn. And basically what it says is that PyPy is better in most cases than GUnicorn is right now. And can be very, very competitive. And for us, the latency isn't quite as critical as the throughput is. So it's really a valuable thing to have there. So yeah, check out that blog post for more information. He goes into a bit more detail than I can, obviously. So learn more. You can go to flask.poku.org, learn more about that. 20 minutes isn't enough for me to get into the details of how to use Flask, but there's this great presentation from a .NET person, of all people, talking about building out RESTful web APIs with Flask and MongoDB. You can learn more about our layer and progress on the Wilson project from there, and you can also check out our open source Big Couch version of CouchDB, which is being merged into CouchDB in the next few months. Thank you. Any questions?